Alright guys, my last video got a little bit interrupted, so I'm going to catch you up to where I'm at. On the top, we factored out a 3, so that left us with 3 times x minus 4. On the bottom, we factored this, okay? Multiplies give 3, adds to give negative 2. So that gives us negative 3 and positive 1. Alright, so nothing cancels. Since nothing cancels, that means there's no holes. Take each one of the factors on the bottom, set them equal to 0 and solve, and that's going to give you your vertical asymptotes. Now let's look at the horizontal asymptote real quick. Degree of the top is 1, degree of the bottom is 2. So degree of top is less than degree of bottom, so that means we have y equals 0 for a horizontal. If there's a horizontal, there's no slant. So draw in your asymptotes real quick. Y equals 0 is just simply the x-axis, put a dashed line there. Dashed line at positive 3. Sorry, that was pretty bad. Dash line at negative 1. All right, guys. This problem, you actually have 3 different segments we're going to look for. You have to look for something, what's happening out here, what's happening in the middle, and what's happening out to the right. So to the left, like negative 2, negative 3, negative 4. In the middle, I'm going to use all those points. So 0, 1, 2. And then happening out to the right, 4, 5, and 6. Okay, I don't use the asymptotes. The reason I don't use the asymptotes is because we know that they're going to give us error in our graph. So now go into our graphing calculator, go to your y equals screen, and type in your function. Okay, we hit graph. And you can see how it has 2 different asymptotes denoted by the solid lines. And then you can see that it's got some other stuff going on out here to the sides. So we go into our table, and there are all my values. I'm going to go ahead and input those into here for us. So negative 2 is at negative 3.6. All right, hopefully you can pick up all those points out of your graphing calculator. Now plotting those points. So negative 2, negative 3.6, somewhere down in here. Negative 3, negative 1.75. Negative 4 is at negative 1.1. So you can see that it's coming up and kind of curling around. It's going to go up close to my asymptote there. So that one's kind of normal. In the middle, 0, 4, 5, 1, 2.25, and then 2, 2. So you can see that this thing's kind of curling down, and it's going to turn and go right back up next to the asymptote. Okay, in the middle, these things are going to look somewhat like parabolas, or they're going to look like cubics, like they're going to come up through here, and then curl, and then go back up through there. But in this case, it's just doing that. And if you need to verify it again, look at your actual graph, and you can see how it's coming down and curling and going back up. Always good to verify with the actual picture. And then over here on the outside, for it says 0, I guarantee you it is not at 0. Well, this one's doing something kind of weird. It's actually crossing across the horizontal asymptote, which can happen. It doesn't happen very often, but it can happen. This one's actually going to do that. So what we have here is 40, 5.25, and 6.29. So this thing's actually coming up and curling across and doing something like that. That does not happen very often. It does do it in this case. Come up and curl across the top of the axis. Most times it doesn't cross the horizontal. It cannot ever cross the verticals, but sometimes it does cross the horizontal, and this is one of those times. All right, so that's what our graph ends up looking like. Now, one more problem that I want to go through with you is a scenario which we have a hole. So, and you're not actually going to have a hole in this problem, so I'm going to have to create something a little bit different for you. Let's make this a 9. Okay, so negative 3x minus 9. So that's what your graph or paper should read right now. So -3, factor it out. Nah, that problem's not going to work very well. Here's the scenario in which you have a hole. So scratch all this out completely. Let's go back to the problem that we had on notes. X squared plus 4x plus 3. And then x squared plus 5x plus 6. We had this problem as our very first problem in our notes. And we factored it. X plus 3. X plus 1. Factor the bottom, x plus 3. X plus 2. All right. And we decided that these two things cancel. So VA, HA, SA, hole. Those canceled. We decided that there was going to be a hole at x equals 3, but -3, because remember you got to set it equal to 0 and solve it. So there's a hole at x equals -3. The function that is left is x plus 1 over x plus 2. Okay, x plus 1 over x plus 2. Vertical asymptote, denominator equals 0, so x plus 2 equals 0. Solve it, you end up with x equals -2 as your vertical asymptote. Horizontal asymptote, well, let's look at our degree. The degree of the top is 1, the degree of the bottom is 1. So since they're the same, we divide the leading coefficients. And 1 over 1 is just going to give us 1. If we have a horizontal, we don't have a slant. Now, very, very important thing here. So we're going to put in our x. We're going to put in our horizontal or our vertical at -2. We're going to put our horizontal at 1. Now, something very important. When typing it into the calculator, you are not going to use the original function. You are going to use what was left over after we canceled. So x plus 1 divided by x plus 2. Okay? That is actually what you're going to use. Hit the graph button, and it'll show you a sketch of what's going on. Now, this is where you've got to be smarter than your calculator. All right, so we're going to create our t-table. Points to the left, -3, -4, -5, -6. Points to the right, -1, 0, 1, 2. Now, right here is something very important. You have a hole at -3. So out next to -3, I want you to put an open circle. That tells us, hey, you have a hole there, to make sure you're not to mess it up. So now all you're going to do is look at your graphing calculator and write down the values. So -3 is at -2, -4 is at 1.5, 1.3, 1.2. Going back the other way, 0.5, 0.7, 0.75, 0.8. And you can pull those values off your graphing calculator. Now, at -3 positive 2, what I need you to do is put an open circle. That shows that our graph does not exist at that point. Okay, it's going to go all the way up to that point. No point exists, and it's going to continue to go. -4 or positive 1.5. So it's doing something like this. So it's coming in, it hits the hole, and then it continues going about its own little business. Okay, just make sure you have a hole at that point. -1. So we know it's coming up. Nothing abnormal over here. Just a normal graph. That's how a hole looks. Okay, so wherever you found the hole to be, make sure whenever you create your t-table, you denote that there's a hole there. That way you can get this problem correct. All right, so that's all of my videos over graphing rationals. You should have plenty of notes over this at this point. I think there's well over 20 minutes, maybe even 30 minutes worth of video. So it should give you a good idea of how to graph all rationals in all scenarios. Now, I hope you've made it to this point in the video. If you have, here's my suggestion to you. Go through, do some of the problems in the packet. You need to do a problem that has a slant asymptote. You need to do a problem that has a hole. And you need to do a problem that has 2 vertical asymptotes. But after 4 or 5 problems, if you understand what's going on, there's no reason to continue to do it. Do as many problems as you need to do. All right? Let me know if you need any help. Thanks, guys.